Now that we talked about overall module and then we discussed decision-making process and phases of decision-making, the structure of your decision, and which management layer you're in, or at least what is your horizon and what type of decision you have to make in terms of strategy or tactics or operations. Now I think you have a bigger and better appreciation of what systems need to be able to do and support us in a certain way so that we are better at our decision-making process, because you have to really understand that technologies in organizational setting, especially in that setting, it's not about technology, it is about decision-making. So having the clarity about what decision you need, what are the features of the decision that need to be supported by technology, only then do you approach the use of technology, because you will get very frustrated if you try to use the wrong technology on a decision that's not aligned with that technology. And some technologies are really great in making sure that we can automate things and support structured decision making, and other tools are designed. It's not about automation per se, but giving you enough insight to help you support those semi-structured decisions or unstructured decisions. So one of the systems that's used a lot in this semi-structured space especially is decision support systems. And we talked about decision support systems in our first module, where we briefly introduced it as one of the systems that allows us to, as the name says, support our decisions, specific decisions that we have to make. And these systems, they tend to be interactive, designed with the decision maker in focus, and it consists of a number of components that we mentioned throughout this course. As any other computer information systems, we're talking about a hardware component, so the physical component, the software, which are the programs that govern the operation. What's critical about this system is the data and its quality that it's needed to support our decision. And then what makes this different maybe from other systems is the modeling that's part of it, that allows a system to support decision and even recommend decision based on this model. So we're talking about mathematical and statistical model in it. So the requirements behind decision support system that, as I mentioned before, they have to be interactive. They have to incorporate the human element to it and the hardware and software components. They can use both internal and external data. Probably the better ones take into account both your company data as well as the external data from the environment in which you're situated in. It has the model. It has to support decision makers across different levels, and it does emphasize that more semi-structured and unstructured decision making. So usually what we have are the components that are here visible in front of us. We have some kind of a database or storage that allows us to combine and import data into it, for whether it's external or internal, into one space. And then we as users, we interact with this data through a user interface. So that's some kind of a GUI, some graphical user interface, where you can key in certain information into your model, and then the engine takes that input from us, pulls the data from database, as well as takes a look at the model that says, based on this data, based on this criteria, this is our recommendation, or this is the output of our DSS system. So examples of that might be maybe a decision that you have to make as a credit analyst, whether you will give a loan or funding to another commercial entity if you're a bank. There might be a model that says, based on these features, balance sheet features of the company, their client base, their existing position on a number of things, once you input the information, it will give us a decision, some kind of a credit rating score, and based on that rating score, there is a sequence of actions that you as a credit analyst can do and approve or not approve a deal going through. Now, these models can be done, it can be as simple as Excel. A lot of companies would do that, and you would do some VBA coding or some kind of layer within the Excel that allows you to feel and look like it's an application. Or it can be more advanced with a complete web layer and kind of standalone product that's designed to do this decision making. So depending on what your first job might be, some of you might be facing these decision support systems, or you might need to be trained in other areas first to appreciate what goes into this database, what goes into that model before you actually in a role that you can use that decision support system. Again, a lot of companies would not call that DSS. They will have their own name for that system, loan approval system or something like that. So this is a little bit academic kind of discussion, that this is the name of the system. And a lot of other systems that are not just decision support systems have a feature that's like decision support system. So it's not really kind of like 0 or 1 or black or white. It's really, there's a lot of gray areas where a lot of systems that are not DSS primarily have DSS features. So just have a good understanding of what that is in terms of the problem is trying to solve, and what are some of the main components of the system. What can do generally, it can do some type of a what if analysis. If I change these things, what would happen? We can do goal seek. We know where we want to end, and then we know some variables that are part of the formula that make that result. So what is the right combination of those variables that goes into it? If I change one thing, how much does the final output potentially change based on that? So you can do some sensitivity analysis. And then the good system will also do some of the reporting, so that you can look at the exceptions and present your results. So you talk about graphical analysis, you might have some forecasting features, simulation, supporting statistical analysis and modeling analysis beyond just the basic decision as well. So those are basic capabilities of decision support systems. And now let's talk about the roles, because you will be potentially in one of these roles. So you might start as a user of that system, credit analyst, just using it. Over time, you might gain enough knowledge and say, you know what, the systems can be better. There are other variables that need to be part of it. The whole model should be more complicated, and we need to get data from different systems. These are not the right data sets. So what you're talking about there is you're a managerial designer. You already understand the bigger picture, how it's using the data, what decision it's supporting, and what are its drawbacks and advantages. And then you can start pulling in your technical designer, a person that understands the underlying technology that needs to build it, whether it's a programmer or some kind of a database administrator, or maybe both of them. They're more technical in terms of their knowledge of the underlying technology. And you might need to bring somebody who's more quant, so the model builder that understands the calculations at the depth that's required to. That can be very complicated and hard to follow. You need to do some statistical analysis potentially that's beyond your capabilities at the moment, because you have other responsibilities. The good thing is, obviously, you're getting now exposure to some of these things, and you can decide, maybe even as you're looking at your major, where you want to land. So, CIS and CS, you'll have a lot of this technical designer, and then other business disciplines would land in the user and managerial designer. And then if you do econ or finance or maybe actuarial science and math, you'll go toward model builder. The good thing is that a lot of technologies are now easier to implement some of this stuff, so your ability to go between these roles throughout your career is not as limiting as it was in the past. So I have seen people move from user to technical and managerial designer rather quickly, because you gain a lot of experience in those different areas. And I have seen also now people moving into modeler just because the tools are easier to implement at this point. So some of the benefits of these systems are probably similar to every system that's out there, but given the fact that you are using a lot of data sets that otherwise you would not be able to consume, the number of alternatives that's being examined is larger, and that allows you to give you a higher quality of the decision. You're able to answer the questions quicker when you have the system. So if you have an unexpected decision, somebody calls you from the field and said, hey, I have a potential customer, needs a decision on this deal, can you support me and tell me whether we should go with that or not? If you have a good ESS, you can maybe turn around in 10 minutes and call back your sales representative and close a deal, while the competitor is going to tell them maybe, come back in 7 days and we'll tell you. So you can have a very fast response to some of the situations that would seem unexpected. You're more informed to start focusing on those one-of-a-kind decisions, because some of the more structured components of it become automated. With all this data and the modeling at your disposal that can be complex, very quickly you talk about new insights and understanding, new learnings. You can communicate much clearer to the input and the operations, so you can see very quickly if you have data issue, if you have a model issue, you have operational issues, procedural issues that feed into that model. You can clearly communicate what the issue is, show them the evidence why the decisions are being made. They are poor decisions, and we need to make some changes in our operations and control of our operations. When you combine those things, a number of things happen automatically, that you're getting better decisions, the breadth of those decisions, the ability to look at a number of things that you otherwise would not, or if you do, you have to throw a lot of resources at those problems. So you at some point are looking at cost savings. Obviously, what is your baseline there? It can be debatable, but you can do more for less, essentially. So we already talked about better quality of decision. It's much easier to be a team player in a team that uses data sets. You can clearly communicate why you are saying what you're saying, and you can support your team better. They can support you. This all leads to just overall time savings and savings in general, where we're using limited resources that you'll always face in your organization. So why not deploy them in a better way, in a smarter way, I guess.